All right. It's time to show up. I showed the fuck up. You showed up too. Good for you. Anyway, this is going to be a fairly technical episode. If you're absolutely uninterested in writing code, you're going to be completely lost. But if you are a fellow developer, a fellow programmer, and you're interested in the actual details of how the terrain loading sort of is working in the game that I'm putting together, this should be useful. One of the problems that I run into all the time with programming tutorials and programming videos in general is people talk all the time about how to solve a specific problem, but they don't really talk about how they arrived at it. There's not enough attention paid to what the problem is, what they're trying to solve, what the different options are, and why they chose the option they did. So we're going to go over that in a fair amount of detail. And the first thing that I'm going to do is, well, first I'm going to go over the problem as it stands. So let me flip over to Clip Studio Paint here, and we'll open this up. And again, we're going to get fairly technical, but we're going to start out pretty simple. Now, first of all, we're using black ink. Using a horsehair brush. We're on a blank layer. Okay. All right. So first of all, you have your coordinate system. This is your basic Cartesian coordinate system that you should remember from elementary school geometry. And as usual, you start at 0 in the center, and over to the side here, it goes upward in the x direction. That's positive x. And as you go upward here, it goes in the negative y direction. Now, this may make you scratch your head, but it's because of the way that computer graphics work. We start up in the top left of the screen. So kind of this is where your computer screen is usually. You've got your negative x direction going off to the left. You've got your positive y direction going down. So this is the first thing that kind of messes with your head, is that the coordinate system is different. But this is typically where your screen sits. And you've got the positive direction over here, the positive direction down here, and you've got the negative direction up here and the negative direction over here. So if you've got something sitting right here and you move it to if you want to move it to the left on the screen, then you would move it in the negative x direction. You would subtract from its position. If you wanted to move it to the right, you would want to add to its position. You'd want to add to the x direction. You want to make it move up, you subtract from y. You want to make it move down, you add to y. All of this is fairly simple. It's not all that difficult to work out and figure out. But the situation that I'm looking at is when I'm walking up here toward the top of the screen, when I walk off this edge of the screen here, I want to come back on at the bottom of the screen, okay? Now, typically you would have this in something like, in a game like Pac-Man, you have the little tunnel that runs through the middle, and when you go out one side of the tunnel, you come back in the other side of the tunnel. Now, in arcade games, way back in the day, what they used to do is they would just move you, the character, to the other part of the playfield. And if the playfield wasn't scrolling, if the playfield stayed where it was on screen and your character moved, that would be the way to do it. But that's not how games like Vampire Survivors and like Yandere Survivors, which is what I'm working on right now, are typically working. Typically, the playfield is scrolling around and your character is staying in one place on it. As you move your character, it's really the world that moves around on the screen and you stay in the same place. So what I actually want here is, when I walk off this edge of the world, I want to come back on this edge of the world But the easiest way to do that is not to move my character from here to here. It's to move the world from here to up here. So that's what I'm trying to do, is to set up a system where as I move off of one edge of the world, I move on to the opposite edge of the same world. So as I move off the top edge here, I move on to the bottom edge here, but what's actually happening is I stay right where I am, and the world is moved to meet me. So the way we make this happen is we have our tiles of the world. And around the edge of the world, we have a threshold. We have this little area here. And when your character enters this area, that triggers the game to say, okay, we need to move the world into the path of the character. So these two tiles would move over here. If I moved off of the bottom edge, then these two tiles would move down here. And that would automatically update the edges. So in order to make this happen, each tile needs to have a notion of, first of all, how tall it is and how wide it is. Actually, we would do width, height. So we would start at 0, 0, because that's typically where you start a game. And then over here we have the width of the tile and the height of the tile. And then we have an edge threshold. We have a vertical edge and we have a horizontal edge. So we need to save that distance somewhere. We need to save that distance somewhere. And we need to save this distance somewhere, the width and the height. And what happens is, as you move onto the vertical edge, if you move onto the vertical edge, then the other two columns, the other column needs to move over into your path. If you move onto the horizontal edge, then the row needs to be swapped down into your path. And that's a fairly simple concept to think about. If you just think about it in terms of, if you had, we got like some index cards or something around here. We must have some index cards. We probably have a deck of cards sitting around somewhere. Let me see. There we go. So what you've got is you've got your 4 tiles, and as you move off of one edge, you just move the other tiles over. And it's the same thing when you move downward. When you move downward, you have tiles on top, tiles on bottom. The tiles on top move to the bottom, or the bottom move to the top as necessary. I'm still sick. I'm better, but I'm still sick. So anyway, we know the information that we need to save, okay? So first of all, we need to know where our tiles are. And our 4 tiles I've got over here, they're named ground 1, ground 2, ground 3, and ground 4, because I'm not very imaginative. And then each of these, we save a reference to that in our in our Playfield. So we're going to save a reference to each of those. Hold on a second. So we're going to save a reference to each one of those. And we're also going to save a reference to the player because we need to know where the player is. So we have our 4 different ground tiles. We have the player. And as we just said, we need to know the width and height of the tiles. We need to know where the vertical edge is and where the horizontal edge is. All of this we are going to save so that we can refer to it later. And you'll see here that what I've got is I've got everything initialized to an early value so that I can tell there's nothing in there to start with. And it's in the ready function. The ready function of your object in Godot is called when the entire node tree is full, your game is loaded, and it's ready to go. So you know everything in the tree exists at this point. And that's when it's safe to get nodes out of the tree. So what I start off with is I get the player node, which is the first thing that I need a reference to, and I get the 4 ground tiles. I get those into my 4 ground variables, G1 through G4, and then I start with the ground 1 tile, which holds the master size and position data. Even though I have everything initialized to where I want it, I'm going to use the first ground tile, G1, as the one that holds all of the mastered information about how big the region is and where the positions are going to be. So working from the region, I have a rectangle 2D, or rect2, that holds the region information, and I have a vector 2 that holds the position. I set the width based off of the region size. I set the vertical edge based on 1/4 of the tile width and 1/4 of the tile height. Now, this is sloppy, okay? And I'm just doing this early in development because what you really want to do is you want to base this off some notion of how large is the viewport. For example, I've got the region rectangle over here. It's 3840 wide. On a 4K monitor, as you start getting close to that, okay, you're going to have this big empty space on the side of the screen where nothing has been swapped in yet, because that's too small. However, during development, that's not a huge deal. That's something that you could worry about a little bit later on. I want to make these substantially larger. I'm currently thinking of making them about 16K on the side. So because I don't think anybody's going to have like a 20K monitor anytime soon, I don't think that's going to be an issue. But using these kind of magic variables here, tile width and tile height, doing it in the last 1/4 of the tile is not a terrible idea, but it should also be keyed to the idea of you want the tiles to swap before the player can see the empty space that the tiles are going into. Typically, you would calculate that here. I don't bother because, again, early in development. Now, once I get the region size for everything, I set the region rectangle for everything to be the same size because I want all 4 tiles to be the same size. And at that point, I set the position of my first tile, the ground tile, to be at 0, 0. And then I go around and I set the positions of all the other tiles so I know exactly where they are. And I set them in a counterclockwise spiral. So what that ends up being is I have set the ground 1 tile here at 0, 0. And when I set G2, I say, okay, I want to subtract, if you look over here, oh, come on. I want to subtract the tile height from the Y position. And subtracting the tile height from the Y position puts G2 here. Now, because we still have the tile height subtracted from the Y position, when I then subtract the tile width, G3 gets set here. And finally, I add the tile height to the Y position, and that puts G4 here. So I know when the game starts up, this is the layout of my tiles. This is always the layout of my tiles. And no matter what happens, there are only a couple of different configurations that we can ever have, okay? And those configurations are, we can have G1 and G2 on the left or on the right, and we can have G3 and G2 on the top or on the bottom. So what we end up with is these 4 possible layouts of the tiles. Those are the only 4 possible layouts. The only thing we're ever doing is we're swapping the row from one side to the other, or we're swapping the columns from one side to the other. So we have a limited number of possibilities. You can do this with more tiles, of course, but it gets more complicated. Now, when we scroll down here to the process, the first thing that we do, every single frame, we check this every frame, we jump in and we get the position of all 4 of our ground tiles, and we get the position of the player. And then we go through the little dance where we go, okay, if the G, remember, we know that G1 and G4 are next to each other. When the game starts, we have G1 and G4 next to each other like this. But, depending on what happens in the game, we could have G1 and G4 in this order. But they're always going to be in one of these 2 orders. It's one or the other. So what we do is we check and see if the X position of G1 is less than the position of G4. If it is, then we have G1 on the left and G4 on the right. If it's not, we have G4 on the left and G1 on the right. But now that we know which one's on which side, we're going to check and we're going to see if the player position minus the edge of the tile that the player is on, the leftmost tile, if that's less than the vertical edge measurement, then we're in the edge. So if we're within the edge, then we want to swap the tiles over. So we take tile 4. We know tile 4 is here. And we know tile 3 is either above or below it. It doesn't matter which one, because either way, that's got to move over to here. They've both got to move over here. It doesn't matter whether it's above or below G4. We only have to move the tile width. So what we do is we take both of those and we set them off of the G1, the ground 1 tiles, tile width, because we know that ground 2, whether it's above or below, its edge lines up with G1. So it's in the same place as G1. We can use the edge of G1 to position both of those tiles. And we continue doing this. We move 3 and 4 to the left, or we can move 1 and 2 to the right. Here we do a little bit more work, because again, what we have is we have the player position minus the tile position. But this time, what we're looking at is we're looking at whether they're going off the right edge. So this is tile width. And this is the vertical edge. So the tile width minus the vertical edge is the area that we don't want to be passed. And you see the tile width minus the vertical edge. If the player position minus the tile's left edge is greater than this, then we're in that area. And again, we swap the tiles. And we just go ahead and we do that for all of the 4 different locations, all of the different 4 ways that we could be close to the edge. But we don't want to do all of this just right here in this one space. What we want to do instead is we want to have something clean and simple So what we have instead is the update tiles call. Now what update tiles does is it just updates everything. Now all of this code right here, there's nothing wrong with having all of this code. It's just that having it all in the process function craps up your game logic, and it makes it much harder to understand. So instead, what we want to have is, we want to have the update tiles function. And that way, when you look at your process, instead of seeing all of this code, you just see the one line, update tiles, and then you go and check the update tiles function. What does the update tiles function do? It gets the player's position, and it says, is the player near the left edge? Swap the tiles left. Are they near the right edge? Swap the tiles right. Are they near the top edge? Swap the tiles up. Are they near the bottom edge? Swap the tiles down. That's it. Then we're done. Now when we look at is near left edge looks suspiciously like we already did. It just checks to see whether they're close to the edge. It does one thing and it does it well. That's all it does. And you'll notice that what we do here is we check the position of G1 and G3. And that's because G1 and G3 are always going to be at diagonals to each other, which means one of them is always going to be at the top and one of them is always going to be at the bottom. One of them is always going to be at the left, and one of them is always going to be on the right. So these two, we could also do this with 2 and 4. But because they're at diagonals, we know that they identify the extent of the window, because that's where their corners extend to. They definitely represent the entire playing field. So we start with G1 and G3, and then we have edge. Now the edge is just the edge that we care about from this. So what we care about here from the left edge, and what we care about here is the right edge. But you can see that the masks that we're doing are a little bit different. Is that right? Yeah, that's right. Okay, yeah, those work. So we just do that for all 4 of the edges. And then after we do that, then we do the swapping tiles. Now you'll notice that there is a minor inefficiency here. And that inefficiency is that we're getting the position of the G1 and G3 tiles 4 times. This is a calculated risk. There's a lot of space to do a lot of calculation in a game loop, so don't worry too much about this. But to move this out of here and up into the top level where we don't have to check them over and over again, that would make the code more complicated. I've made the call to be a little bit suboptimal so the code is less complicated and easier to understand. It makes all the code look more or less the same, and that way, as you're going through, you go, okay, that looks right. Is near right edge? Well, that looks right. Is near top edge? Looks more or less the same. It looks right. If nothing's going wrong, everything works fine. Well, that's a little tautology. If nothing's going wrong, everything works fine. So the kind of shit professional programmers say all the time. But I made that call because it doesn't actually matter if you make a few additional calls, as long as it makes your code easier to read. Trying to optimize that out now is way too early. You want to wait until you actually have performance problems before you start trying to solve them. Don't try to solve a problem you don't actually have yet. And then we come down here, your swap tiles left, right, up, and down. Those are, again, the same basic thing, but we've moved them off into their own little functions, and by moving them into their own little functions, we make the code easier to understand. And that way, you only have to look at one of them and figure out, how does this work? Well, it works just the same way over here. It's like up here, swap tiles left. As you go through swap tiles left, you see, well, it sets everything to the G1 pos minus the tile width. And then you go down to swap tiles right. It's like, oh, now this is G1 pos plus the tile width. So it starts from G1 pos to the left and to the right. And then you can figure out pretty easily how the up and down work. And let's go ahead and build this to show that, first of all, it works. And then we'll hit run. And it's not working. Isn't that just perfect? What is going on here? Huh. What is the issue there? Okay, looks like we're going to be doing a little bit of live debugging here. So, what did I mess up here? You always mess stuff up. That's always the thing that goes on. Player get position. If is near left edge, player position. Okay, so we had in the output debug adapter types. Yeah, condition path is healthy. That's fine. We go ahead and hit stop there. Resource file not found. Huh. Wonder what that's about. Swapping tiles right. Tiles left. It's swapping tiles left and right repeatedly. Here we come all the way up to the top. Tiles right down left. Ah. Okay, so if is near left edge player pause, swap tiles left. Okay. So it first goes is near right edge. So first thing it does is swap tiles right. So when we start off, it thinks the player is near the right edge. So get position, G3, get position. G1 pos, okay, edge equals G1 pos X, G3 pos X. There's not supposed to be edge. Pos X greater than tile width. Okay. Just the right edge. Yeah. It's near top edge. That works. It's Y, yeah, okay. Wonder how I got that wrong. Okay, swap tiles less. Okay, let's start with. Okay, yeah. Let's build that. That should fix it. Yeah, there we go. So if I come all the way down here, you can see that these swap down, and you'll see that it swaps the tiles. You got swap tiles down. Now if I move over here, it should swap tiles right. As I get close to the edge, you may be able to see the Playfield screen scroll in. No, you don't. Swapping tiles right. If I move up, we will again get swapping tiles up. Head over here, and it should swap the tiles left. That is incidentally precisely the kind of thing that you will forget over and over again while writing code. And it never stops. Just like you'll never stop forgetting semicolons. You'll always forget semicolons. You'll always forget the capital P on print for GD print. You will always make the same mistakes over and over again because human beings are fallible. We are flawed. But the point of this is, now that we got that done, having this big bunch of code in here for your process function is a bad idea. You want to factor that down. And the way that you do that is you start out by saying, okay, we want it to be magic. So I started by saying, we're going to call update tiles. And then I wrote update tiles, and update tiles, I went on to say, okay, here's how update tiles works. We're going to need the player position, or we're going to check, is he near the left edge? Swap tiles left. Is he near the right edge? Swap tiles right. All of this stuff was written before the actual functions that do the job got written. And then the whole left edge, right edge, top edge, bottom edge, all of that got written afterward once I said, okay, if it was magic, how would it work? And then once you get that initial kind of pseudocode written in, once you get something like this written, then you write the details of it. You break everything down into smaller and smaller pieces. And that makes your process function look a lot easier because then you can go through and you can go, okay, where is the problem? When you have a bug that you're trying to track down, and you could figure out where that problem is. Just like when we were looking at this, the first thing I did was scroll all the way up to the top and go, okay, the first thing that went wrong is the question of, is it near the right edge? So the question of, is it near the right edge, was not getting answered correctly, and it's because I wasn't doing the correct maths on this. I don't know why I wasn't doing the correct maths on this. You probably saw that as I was initially going over it. But you'll do stuff like that all the time. It'll happen constantly. Now, if you wanted to do this with more tiles, you could do it. If you did it with enough tiles and large enough tiles, that's how streaming from disk works, and that's how they do large-scale open-world games. I don't know how to do large-scale open-world games. I've never tried to do anything like that. I know the basic theory, but working on that scale is kind of beyond me at this point. And anyway, what we end up with here is we end up with a system that scrolls exactly the way I want it to. And you can see that if I move from the blue area here, if I go all the way to the edge of the blue area, then that'll pull in the red area. Obviously, these aren't going to be different colors in the final game. But when I get to the end of the red area, when it pulls the blue area in, the tree in the blue area will come with it. But the enemy that was sitting in the blue area will not. We'll also see that the little bush here in the green area comes along. And this is the kind of behavior that I want. Now, another little trick that you can use is, in fact, let me just kind of demonstrate this. If I go over here to if I go to the 2D display, if I take the tree and I move it over here, so that it's right in between the two areas and it crosses over them, this can actually knit your locations together. It can conceal where that edge is by having something that goes over it. So if I walk all the way over here to the edge of the red area and I get to the edge of the blue area, then I can walk across the blue area. And at the end of it, we've still got the tree, and the tree is now sitting partially into the red area. So that semi-conceals the border between the two areas. It helps to kind of conceal that border. Because when you've got something sitting over the top of it, it doesn't look like there's a wall separating the two. So the idea here is that I'm going to place kind of obstacles and items and whatnot in this area. I have picked up a large set of graphics assets to potentially speed stuff up on this, because the whole I want to do my own art thing is not necessarily all that important at this point. And that may speed things up on actually getting the game working. I do want to point out that the most important thing when you're building a game is the game has to be fun, and this one currently is not. All you do is just kind of walk around a field. And the question you always need to be asking yourself is whether the game is fun. It's always fun looking at stuff. I have a blast looking at how, everything moves around, and I wrote the code that made this happen. And it's really, really cool to see the code that I wrote doing the thing that I wanted it to do. But you have to put that on the back burner and say, okay, now forget all of that. I'm not looking at what my cool, nifty code does. I'm trying to play a game. I'm trying to enjoy myself. Is this fun? No, this is not fun. There's nothing fun about this. There's nothing even interesting about this. Nobody wants to play this game. There's no game here. And if you rush into doing the fun parts of the game, a lot of the time you end up wrestling with the question of how do you make everything underneath of the fun parts work so that the fun parts can stay fun. And I always try to build the foundation first, and that foundation is here. You need to be able to put stuff on the field, stuff that you can walk through, stuff that you can't walk through. And I've got an enemy, but the enemy's got no AI. I need to put some AI on the enemy. And kind of the triple whammy that I have to put together here is I need to have a chest item of some sort, something that you can break and an item falls out. You need to be able to pick up that item, and you need to have just like stuff that's sitting around that can be picked up, you know. And there's also the question of having the player have some kind of weaponry, because that's the important thing in any kind of these horde survival games. You gotta have cool weaponry. But first things first, you gotta have an interesting playing field, and you have to have some way for the game to present a challenge. You need the player, you need the adversary, you need the environment. And anyway, I hope that was helpful. I hope that helped people with something. And, you know, again, do the little YouTube dance, like, comment, subscribe, all that happy horse shit. And, okay, bye.